use in intercity travel is investment in a high-speed rail passenger network, eventually running on renewable energy. Also, putting in bus and car share priority lanes on motorways, having improved information and traffic management systems, and of course, improved vehicle and fuel technology. In Europe, now we have a viable high-speed rail network, we know that rail is a more attractive option, where available, than regional air travel for distances up to 600 kilometres. Therefore, building the high-speed rail lines through international airports, as well as major city centres, will reduce regional air travel. What about biofuels? European policymakers are now reviewing their biofuel targets amid growing concerns of their social and environmental impacts and their high footprint. Second-generation biofuels from waste agriculture like rice husks, stalks of grain crops and CO2-absorbing algae are much more sustainable with lower footprint. A programme of improving the efficiency of power stations is underway, combined with the introduction of decentralised heat, cooling and power facilities in urban areas. These CHP plants can run on gas or waste materials and biomass from local sources. They can be combined with the use of ground source heat pumps to serve a large area. It's estimated that 50% of the reduction in emissions from energy supply could come from this approach. Looking beyond the government's short-term targets for renewables, a promising commercial solution, and one which has a deliverable outlook, is a European renewable power grid that would run on a combination of concentrated solar power from the Sahara, wind power, tidal and stream power from the Atlantic seaboard, and hydropower from the Alps, the Pyrenees and Scandinavia. Hydrogen, derived from renewable energy sources, could also provide part of the transport energy supply and also act as a storage medium for renewable energy. This would require new supply infrastructure like that already being put into Shanghai, with fueling stations around the city. An early and quick win to accelerate ecological footprint reduction is running on information. Provision of information to customers in a form in which they can optimize their daily lives to be as efficient and as comfortable as possible. For example, optimized real-time journey planning for public transport, in which someone could ask to go to a point in a city within a given time and be given a plan based on where buses and trains would be in real time, would transform safety and ease of public transport use. On pollution, there is a virtuous cycle between using waste as a resource and not polluting the air, water and soil. Health costs go down and biodiversity and carbon sinks go up. European legislation has been effective in driving change, but the one area that is lagging behind is in the recycling of sewage and wastewater. If we do this, solid waste can be digested in anaerobic digesters to provide energy and compost, and water can be recycled for use to grow food. Also, fitting water capture and grey water recycling systems into homes can save 30% of household potable water consumption. But also, it can reduce stormwater runoff, so this is another virtuous cycle. The one issue that has to be addressed quickly is the reduction of carbon emissions at coal power stations. Carbon capture and storage is one option which is being developed, with underground storage the preferred option. However, finding the storage at the scale needed is difficult, and carbon dioxide has to go through an expensive and energy-intensive liquefaction process. A more sustainable option, which is still in the early stages of development, is to close the carbon cycle in a shortened integrated carbon cycle system. In this, carbon dioxide is cleaned and separated from the flue gas and passed through a collection of bioreactors in which light, nutrients and seawater allow different algae types to grow quickly and absorb the carbon, releasing oxygen and in some cases hydrogen. Small pilot plants have been created by MIT to demonstrate the viability. The different algae can then be sold, one type used as a fuel for energy production in anaerobic digesters in local urban centres, another as a pharmaceutical product, another for oil production, and the hydrogen from the other bioreactor can be used for transport. In this process, the byproduct has a value, so we believe it has a good possibility of having a commercial future compared with underground storage. Hard city landscapes and hot summer sun lead to heat island effects, with associated higher energy consumption for cooling in summer months. London now uses more energy for cooling than heating. As global temperatures rise further, these effects will lead to health dangers. Increased biodiversity, with green roofs and urban parks and tree planting in streets, will help evening cooling and give the benefit of improved health through lowering heat stress. Another positive link between biodiversity and health can be illustrated by Singapore's visionary approach to biodiversity management in parks. Dragonfly habitats are being introduced to try to help control mosquitoes and the problem of dengue fever in the city. The prolonged use of oil-based fertilizers has denuded the soil of essential nutrients and minerals essential to healthy life, and has polluted rivers, lakes and the sea with nitrates. Fertilizer use can be reduced by using organic waste, full of minerals and carbon, from farming and city sources. This would require substantial investment in the treatment and waste management systems linking urban and rural areas. The same applies to water, as I've said already. Land and rooftops in urban areas can be used for cooperative farms and intensive food production. Research is being carried out into food production inside buildings, in which artificial light is used, together with hydroponics and nutrient recycling from city waste streams, to grow green vegetables and fruit. This takes advantage of new LED lighting technologies and plant science. Control of nutrient supply to plants grown in this way will also enable the mineral balance in the food chain to be improved. Let's now move to low or middle income countries and how they can go directly from the agricultural to the ecological age. Urban developments can be designed as a collection of villages, each being a compact, mixed-use development with a density of over 50 dwellings a hectare. Developments can have green spaces, green roofs, trees in the streets, and high biodiversity reflecting the local ecology. Cultural history can be reflected through public spaces and architecture. A critical priority will be flood protection for people, infrastructure, and also protection of food production land. This can be built into the fabric of the city and combined with the water management system. Walking, cycling and public transport running on renewable energy can be the primary means of getting around, with local stops for everybody. Goods can be delivered with green vehicles too. Quiet, clean vehicles can mean quiet places to relax in the city. Social services like hospitals and schools can be located so they're accessible within the community. Where there is no existing electricity grid, use of local renewable energy supplies from solar, wind and waste biomass are very cost-effective for electricity heating and cooling. Waste can be used in future construction. Buildings can be designed to use very little primary energy and can be integrated with the food production systems in the city. So, cities can enable people to live within environmental limits.